Hello everyone, this is CSC 575 final project presentation. Our topic is H&M personalized fashion recommendations. So the data analysis and machine learning can help customers make personalized recommendations. It can also help company improve the revenue by a slight change. So our goal of this project is to build models to save customers time and prevent users from missing out on the best option based on the customer's past purchase. So during this project, we first do the exploration to find some insights and then to create few models, and then we compare these few models to find the best one. The data is from Kaggle website. There are three CSV files. First one is article file, which is the details for each clothes available for purchase. The customer file stores each customer ID. The last file is the transaction file, includes each customer's purchase on each date, as well as additional information. By the knowledge we learned from this course, we built a content-based filtering model. There are two models with different article features. The basic logic for the content-based filtering is to find the most k numbers of similarity items from the article database for the target item, which is the user purchased item. Since our dataset is huge and the running quotient similarity takes a long running time, we decided to use jQuery similarity and use SIT to store the data to save the time. First, I create two sets to store all the data locally to save time by running line by line. As you can see from the left corner, one stores all the articles ID and the articles features that we want to analyze. Another one is each user's purchase article IDs. Then by passing these two sets into the jQuery method, we can get the most k numbers similarity items. To get accuracy, I first store all the predictions for all the transaction article ID from the trained datasets, then running the test transaction dataset to get the percentage of all the user purchase item in the recommended list. For the content based with 5 features recommendation, the accuracy is 0.18%. And for 11 features, the model is 0.2%. Then I did two rule-based model by grouping article ID and the customer ID to find the most K items among the transaction datasets and the top K items in the past 3 weeks. Same as the accuracy method for the content-based filtering, I first get two lists for top K items and popular K items, then running the test datasets to get percentage of the item in the recommendation list. The accuracy for top K items model is 0.05%, and the top K items model is 0.2%.
For the collaborative recommendation system, we want to convert the transactions into customer profile, finding KNN profile using cosine similarity, and then we have to create a binary matrix for the KNN customers and use it to predict and recommend articles by modified matrix vectorizations. For a data structure, we want to converting the transactions into customer profile by using dictionary. So we have the customer ID followed by a set instead of a list with article IDs. For that to use it to eliminate duplications, because we don't care how much the customer have bought the same items before, but only the item they have bought before. Here we have a demonstration so how the recommender was calculated. So here we have the targets with ones and zero. Zero means that the customer have not bought the product before, and one is that they do. And then we have to calculate the means of each customer and the similarity score. And so the first step is to weight it by the customer mean. So we have to use their ones and zero, the binary, and divide by the means of the customers to get the weighted score. And then we have to multiply by the similarity. By doing so, we use that to rewarding a customer that is closer to the target. So let's say for customer 2 is closer to target, so at 0.7 similarity, so that his score is way higher compared to the other customer with a lower similarity score. And then after that, we sum up the articles together and getting the total score of the articles. So in the greens, with 1.33 for article 2, we will recommend this to the target, while Article 5, 3, and 7 are graded, highlighted in gray, are the products that the targets have bought before, and so we want to avoid recommend these 3 items, and followed by Article 4, 6, and 1 with lower score. We iterate the data over 20 times to find the best K value, and at K value of 50 with an accuracy 9.99, we think is the best K value for this data set.
Comparing these few recommender systems, the content-based recommender system accuracy is 0.2%, and only with 5 features models accuracy is 0.18%. For ruler-based recommender, the top 15 models in the past 3 weeks, the accuracy is 0.05%, and for the popular 15 items among the entire transaction dataset is 0.29%. For the collaborative-based recommender system, accuracy is 9.99%. As you can see, the last model performs the best.
For future improvement, we want to incorporate more customer features filtering to reduce the size search for the KNN, and we should also include a season, time-sensitive where, and geographical location filtering. For the recommendation type, we do want to have a system to recommend similar tops that the customer has searched before, pants, shoes, accessory, and etc. And then we want to have a product relevancy update to avoid recommendations on lower stocks or out of stock products. And we also want to incorporate customer clothing size. So we want to search whether or not the recommendation have been stock for the customer size.